Yeah, good. Do you hear me? Is it on? Yes. Test, test, test. Okay. Um, yes, it's some kind of a special paper. It is a literature review, and it is about validation. And since we are on a simulation conference, I should not be. Wait, I will have a laser pointer soon. So since we're on a simulation conference, I shouldn't be talking about the importance of simulation. So if you are into, so I'm mostly discrete event simulation, stochastic discrete event simulation. And you know, if you read a good book like The Law and Kelton, there are chapters about how you gather, how you build the model, what you need, what data you need. You need to statistically analyze the input data that you use in your simulation. And you do, since you have stochastic simulation, you do have to do repeated runs. You have to take care of rare events. And after the your simulations, you need to analyze statistically the output of your simulations to have a meaningful and reliable analysis results. And what is validation? You all should know it is the validation connects the model you build inside your computer to the real world. And validation is one of the processes in modeling and simulation which cannot be formalized. Yeah, because you build the model inside the computer, and you have to look what the model in your computer says and how reality is. You have to look into the reality, and you have and the reality you decide in your head what you capture from the reality and put into your model, and that is the non-formal aspect. That is some call it, that is the art of modeling, the human art. Because once you have something like a formal thing, you can transfer it into different models. You can do verification. Verification is the process to have one model and you compare the other model at the implementation if it meets the specification. This can be formalized. This is all technical. This can be proved, but that your model is meaningful for the reality, that is not really to prove. That can only be yeah, you can give hints. So many okay, maybe a little bit more about my motivation. Once there is this, for me it's like a famous, a good paper from Pawlikowski. Pawlikowski did a literature survey in 2003. At the other end of the modeling and simulation process, he noticed that many of the works, especially in simulation and telecommunication networks, this is especially easy if you have like network simulators, NS2 or the WALNet or some, there are lots of commercially or semi-commercially network simulators. You can easily make a scenario and play around with some parameters, and you have a paper about a new protocol. And he noticed that many of those studies had no real meaning because they did not, because it is a highly stochastic simulation, these telecommunication networks, you know that there's in the Ethernet protocol, you have stochastically repeated, if you have a collision, then you have stochastic repeated intervals. So there's a lot of stochastic things that can happen. That means you have to do multiple simulation runs and analyze the results statistically, having a mean and a confidence interval that describes you with what confidence this value might be the right one. And he found in this paper that a huge amount neglect the art of modeling and simulation. I mean the craft works, the hands-on methods that you teach to the students, the basic methods, they are neglected in many of those studies that are published. And with this in mind, I was getting more and more like fed up when I did reviews for many conferences, also good conferences. And what the people did was they programmed some simulation. They said, I have a model of blah, 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 and I ran it, and then I changed some parameters, and I optimized some parameters, and then I get a better result, and that's it. I have a paper, I have a dissertation. Yeah, and I read lots of papers, and I say no, and in the review I often say no meaning, no result, no meaning to reality. No, often it's the so why do you do modeling and simulation? You plan a system, or you want to optimize a real system. That means you have, if you just have a random simulation, then it's like a computer game. Yeah, it's like The Sims or SimCity or whatever. It's just moving objects that do something in their own world, and you have no real. But you would not, I know, bet your life on it. Yeah, because that's what serious simulations are for safety critical systems. And so I read these meaningless papers often, and then I think, is it just my view, or can I have found my meaning, my opinion on data? And so we started to make a review of literature, and using a methodology. I will come to that in the next slides. And often the people say, my model has been created carefully. I was thinking a lot, and I used sensible assumptions. But even in the simple model, if you have the MM1, if the DD1 queue, that means you have an arrival process, a service process, and that's it. It can, if you model it wrong, then you can have completely different outcomes. Yeah, everybody might know, should know, I don't know. If you have the the DD1 system, if you have deterministic, every 1 minute one customer comes, and exactly 1 minute he goes, then it is a stable system. You have maximum queue length of 1. But if you have a Markovian arrival process and service process, then with the mean, one customer comes 1 minute and leaves 1 minute, but it has a variation. The MM1 system has queue length. If you have the same value of 1 for arrival mean and service mean, has the queue length of, that's your part to show your expertise as modeling and simulation, I mean queuing theory. It is unstable, it has infinity, yeah? So by making a small error, and this error is easily to be made, because if you watch the system in reality, what do most people do? They click, 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 click. Okay, I have 5 arrivals in 10 minutes, so my mean arrival time is 2 per minute, 1 every minute. And people don't care about variation. Yeah, and you see, the variation here makes the difference if it's stable or it's perfectly safe. one queue length of one only. And this is the simple system. Imagine you have a real complex system. You have like 100 or 1000 places inside your model where you have to make this decision. Do I consider only the mean? Do I have information? Often you don't have information about the second moment or the third or the fourth. It can also be interesting. Yeah. So so this is, people think, and often it works on a certain level. Of course, it works well. Not every bad simulation gives completely crazy results. That's also clear. But as I said, if you want to bet money or your life on it, then maybe it should be done correctly. So this was my enthusiastic talk. Now to the boring methodology. There's a methodology how you conduct a literature survey. So how many time do I have? Until 10:30 or no? Until 11 or only 20 minutes? Lots of time. No, but because my timer here says I have used 22 minutes, but this is I started it before. Yeah, now I know. Yeah, no problem. It will be quickly, because if someone is really interested, he can read the paper for the content. So we use a methodology. We do not just read something and have our opinion. There's a methodology that has several steps. Formulate your research questions in advance. That's always a very good thing. Also, if you have a simulation study, not do something and then look, oh, what can I answer for what are the answers I found? What are the questions that I should have posed before? Then identify the good literature, identify how you reduce at the moment we have too much literature, so identify search terms, and for that also identify validation methods which we are searching in the literature. The research questions are, is there any information about in the papers, is there any information at all about the validation? Do the authors have thought about validation at all? If yes, which methods have been used? Is the paper, is it an academic study with no connection in the real world, or is there a real data, real problem behind that, so that validation could be conducted at all? So, and which weight has the validation process during the model development? So these questions we want to answer. And so we find some A star rated sources for our papers, for our sources for our search. We have the Winter Simulation Conference. We have the Simultech conference. And I don't know why this turned out in Building Performance Simulation Association. It's about building buildings. I don't know why this is a very special, very high quality conference. I don't know. But I would say in this context, it's because you bet money on the results. Yeah, if you construct a building and it doesn't work, then it costs you a lot of money. So this should be especially be prone to validation. And there is the ACM. So this is the simulation. Oh, yeah, this is the ACM simulation chapter, the transactions. Okay, not surprisingly, we identified this. And so validation is especially a topic if you have stochastical discrete event simulation. So we were separated, or we had to look, what do we have here? So lots of simulations were discrete event simulations, some also agent-based, and some hybrid. And here is the, okay, it's not surprisingly, it's not very interesting. So it enhances the fact that we wanted to deal with discrete event simulation. So now the first step would be in which abstracts or in which papers do you find the term validation at all? And this is sometimes well over 50%. That's not too bad, I would say, because we reviewed a lot of papers. So sometimes it's maybe we had a paper that was more about a methodology where you have a modeling formalism and you develop it further. And of course, you don't do validation inside this paper. So there are, of course, kinds of paper which do not need to have a big validation part inside it. So from this perspective, it's not too bad to have like 50 to 70% mentioning validation. Okay, this is nearly the same. Then what's also interesting is what validation methods. So as I said, the validation process is not very formal thing. Yeah. So there are things like phase validation which it means that you have experts watching your model perform and they say, okay, this is doing like we do it in reality. Of course, you have the historical data. It's a little bit like the new AI and neural networks and all machine learning methods. Machine learning models are also models. In this sense, you have data, you want to approximate this data, but you don't want to overfit. Same to simulation models. You have you want to reproduce what the old system does, but not to this extent that it overfits, that if you adjust parameters, that it goes somewhere to nonsense. Yeah, so the historical data validation is maybe in the light of the new development of the machine learning algorithms is the maybe the up-to-date algorithm for validation, because many methods exist to avoid over and underfitting. Yeah, and the same methods can be applied to the simulation models. Okay, then lesser known models are not so often used. Of course, these two methods are used a lot. Yeah. Okay, phase validation, we just have a look at it and we use historical data. But without real validation measures are a lot of papers. And so we just saw that they mention that over 50 to 70% mention validation, but now we find out that they might mention, but over 60 to 70 mention it, but don't do it. And so we have this between mentioning and doing it good. We have this gap. So we introduced some scale to rate the validation process from A to D, where D is none, A is done very well. And as you can see, these numbers below here, they stay the same, but also the quality differs. It's only like no, not even 20%. 1/5 of the papers do a very thorough validation process. And okay, the medium well, or at least a little bit validation has been done. Okay, but if you look at here, then maybe 50-50. Yeah, but still Okay, maybe this is also an article or a work that should lead to some discussion. But as I said in the beginning, so this is already my last slide. In my view, that was the motivation. Too many papers published meaningless work, or maybe dangerous work if really, why do we do this publication? Except for getting PhD or getting funding or keeping our CV up. We do a simulation or simulate some things to find something out that other people read and say, okay, they found out if we by simulation, if we have this chemical reactor and we use parameter blah instead of blub, and then it will be safe and the performance will go up. So we build our real system after what we found in the literature, and we invest money and safety because it can blow up, yeah, and build it based on what we found in the literature. This is the maybe normal thing why we should do that. And considering this scenario, that the paper's contents or findings should be deployed in the real world, would you invest money or your life on it, on the papers you read or you review, or to be self-critical, the papers you publish? Okay, that's it.
Are there any questions?
Hello, thank you for the very interesting talk. I'm happy to see more acknowledgement for the importance of validation and simulation, because it's something that's very easily overlooked, I think, in a lot of papers, as we clearly saw as well from the results. For slide number 10, I'm kind of curious, how did you exactly discern the quality of the validation? Because it can be very specific to the type of model that's being built and for what purpose.
I must say, I don't have it in mind. We have to look it up.
It's written in the paper, perhaps, because I didn't see it yet, so that's why.
It's not described in detail in the proceedings. Yes.
Okay, then I'll take a look at it, because I'm very curious as well. And on a similar note, actually, from your experience, to what extent is, for example, you have a paper and they do like a very bad validation, but they describe it as like something very trustworthy. But when you look at the details, it's horrendous in validation. It's actually not trustworthy at all. Do you think that is, in a sense, like worse than saying like we didn't validate it? Or do you think that there's like a weird balance?
What should I say? Of course, it would. Yeah, it would. In only my personal view, it would be good if people would be more honest and modest and say, I did this thing, but it's purely theoretical. Please don't use it in reality. It is only a hint for in which direction you could go. But I think the current science or publication treadmill is not working like this, at least not in Germany. You have to, the little result you have to go like big.
Everyone believes their work is like the next step in the real.
From the PhD student and also from your, to write your final report, you have to write it like thing and it will change.
Yeah, in a sense, I can imagine it can be quite dangerous.
Thank you for your presentation. It's really on par with exactly what I'm doing, since I submitted to WinterSim and waiting for the acceptance, and I do stochastic discrete event simulations. And so for the validation, I use different methods. But concerning the historical valid, I mean, I'll give you a presentation tomorrow, so you'll get more into that. But there are several ways to validate, and some use multiple. Yes. For instance, I can do animation and also historical data validation, and you can combine these. So you can also say which study is this, and that. No, it's just not only one validation method for this. And also, have you done this also for journals? And if you identify like top, because my supervisor said, oh, you have to submit to Wintersim because it's the best and simulations, let's say. And in the same time, I'm trying to find journal papers on simulations. And then would you rate journal papers that are higher than Wintersim in simulation, and have the techniques of validation been also maybe investigated in those journals in parallel to the proceedings?
I mean, we have the ACM journal for simulation. So we have one journal, and the winter simulation is, I think it is the most renowned conference. But of course, I mean, the review process also has its limitations.
Mhm.
Yeah.
But I mean, not just conference proceedings, but for journals, do you think that the quality is even higher than what these journals for proceedings request?
Yeah, and
Oh yeah, Tomax is a journal. Okay.
Tomax is a journal, so and
Okay.
ACM, some people rate ACM higher than IEEE, or I don't know. So, but it's all comparable. I mean, from they all have a big part of not so well, and the other half is between good.
So for the search for validation, did you read each paper individually and try to see if their validation was correct, or did you search keywords, say dimension validation, so that means they talk about it, or how did the search?
I think in the paper we describe how we first try to find papers, and there will be like hundreds, too many to read, and how we then reduce the amount, and then the last amount of papers which we filtered, that we analyzed thoroughly by reading and really reading and find out what they did. But of course, it has also its limitations. So it depends on. So I didn't read all the papers. It was my colleague, and it depends on the experience how you rate it. So I also want to be honest. It shows that there's a deficit, but maybe the situation is not so bad. Maybe it is, but I think to really rate the situation, you would need a group of experienced people and like a group decision and a bigger project to really analyze the quality.
And also one method, I think it was mentioned, but independent review of the code, for instance, if you have like a simulator, then you have someone else use it and try to independently without bias. So test your code and validate it independently. This is a method that's very robust because you don't interact with the review process. So it's like someone else doing the review. So that's used a lot of the time, but then there's concern about intellectual property of your code. So you cannot do that all the time, but
yeah, it's not easy. Yeah. Yeah. You mean so yeah. Yeah, so you mentioned the quality process also independent from simulation. You mentioned Science, the biggest journal, and if we talk about the quality of the of the general science, also not only computer science, um, of course, and also in computer science, we have this discussion about reproducibility. That means people publish something and no one, there is no funding to do the same thing. Yeah, but it would be necessary to do the same thing and find out, is this, because this is this is one of the general things we demand from research work, to be reproducible. Yeah, but and there are many studies that try to reproduce, especially in medicine, to reproduce, and I found out there were many fakes or non-reproducible, or in the data sets important parameters are missing, or the experiments are so special that no one will ever reproduce it. And try yourself, find in the computer science papers, find in the papers, find if there is all information that you can reproduce the simulations. So if you talk loud, I can hear you. It's a difficult question, the quality of the. You can just talk to me, or.
Thank you. So I found very interesting the last question you asked, which is, would you invest your money? Yeah, based on those predictions. And the topic of validation is very important, not only in simulation, but many domains. And for example, there is people that are supposed to invest professionally on validated ideas. And then the question comes, was that idea validated sufficiently to generate results? For example, in the startup world, there's the lean methodology, and et cetera, et cetera. And I wanted to ask you is, what is your recommendation, whether you're validating in the realm of simulation or any other realm of technology, market? What is your practical advice? Should we validate more? Should we have more focus on scientific method? Should we have more focus on iterations? Should we have more focus on details? All of the above, none of the above?
Okay. So and if I understand the question, what should we do to, yeah, I already pointed out that it's not so easy. The easiest thing is that if every paper would be done correctly with using the correct methodologies, and also including validation, verification, and statistical analysis. The problem here is a little bit the research organization now. People want to publish fast and much, and you don't get funding for other works, for research for critical research. I mean, also there's also in the optimization, in the big, CEC, the Congress on Evolutionary Computation, there's also, they are publishing hundreds of optimization algorithms, like buffalo herd, krill herd, or all like biologically inspired, but it's algorithmically, it's the same. You have a population of optimizing individuals, and they combine with certain parameters, local and global search. It's all the same. And there's inside this community, there's also a group and saying, stop. Yeah, don't accept those papers anymore if they are only talking in metaphors and not if they are on algorithms and technically. Yeah, so we know in many cases what is the right way. Also what I said, that AI, that machine learning, that these are models, and it's much more usual that you do a good validation, because you don't see the internals of the model. You only rely on the validation, on the confusion matrix. This is the only quality parameter you can give to your audience. Yeah. So it can be done in a good way, but it is